Okay, let's unpack this. If you're managing servers, any kind of IT setup, really, you know the feeling. There's always that task, installing something, deploying code, tweaking a config file, and you have to do it over and over and over on machine after machine. It's tedious, right? And honestly, it's easy to make a mistake. Plus, it just burns through time you could be using for, well, more interesting problems. How much headspace does it take just trying to keep everything consistent?
Oh, it's a huge drain, a real silent killer of productivity in IT, like you said. And it's exactly that kind of repetitive work that automation tools are designed to tackle.
Right. Which brings us neatly to Ansible. We've been digging into the sources you provided, the official docs, a pretty good beginner's tutorial. So our mission today is to really pull out the key ideas. What makes Ansible tick? Why is it different? And crucially, how can you actually start using it? What are those first practical steps?
Yeah, the goal isn't just defining terms. It's about understanding how Ansible can shift your whole approach to managing infrastructure.
Yeah.
It's a different mindset.
Okay, so let's start there. Based on the sources, what is Ansible fundamentally?
Well, the docs call it an open source automation engine. That covers a lot,
Hey.
IT orchestration, deploying apps, managing configurations. But the really core idea that comes through is defining your infrastructure as code.
Infrastructure as code.
Yeah.
Yeah, that phrase definitely suggests moving away from manual clicks or one-off scripts. So why Ansible specifically? If someone's already managing systems, maybe using scripts already, why should they pay attention? What benefits really stood out in the sources?
There are a few big ones. First, and this comes up a lot, is its simplicity. The sources really highlight that it uses YAML for its automation scripts. They call them playbooks. And YAML is, well, it's designed to be human readable. That really lowers the bar for getting started.
So you don't need to be a hardcore programmer necessarily.
Exactly. If you can handle structured text, you can probably get going with Ansible without a, super steep learning curve. That's a big plus for busy folks.
Makes sense. That accessibility is key.
Yeah.
Who else?
The agentless part. This is where it gets really interesting compared to some older tools. Ansible doesn't need special software, no agents, installed on the machines you want to manage.
The managed nodes, they call them.
Right, the managed nodes. It just talks to them using standard protocols. SSH for Linux and Unix, WinRM for Windows, stuff you're probably already using.
Ah, okay. So it uses what's already there, rather than making you install and maintain another piece of software on every single server.
Exactly. Less overhead, fewer agent problems to troubleshoot. It simplifies the whole setup of the automation system itself. Then beyond that, the sources point to its power. Meaning it can handle a huge range of tasks. Simple things like creating a user or restarting a service, sure. But it can also orchestrate really complex multi-tier deployments across lots of servers in a specific order. It scales up.
Okay, powerful. And there's another term that always comes up with configuration management, idempotent. The sources say Ansible aims for this. What's that mean in practice? Why is it important?
Right, idempotency. It's crucial for reliable automation. Basically, it means you can run the same Ansible playbook multiple times, and the result will always be the same. The system ends up in the state you defined. If something's already configured correctly, say a package is already installed, or a file has the right content, Ansible sees that and just skips the step.
So it doesn't just blindly run commands every time.
No, it doesn't throw an error, and critically, it doesn't accidentally repeat an action that might cause problems if run twice. It's focused on the desired end state.
That feels like a fundamental difference.
Yeah.
You're describing how you want things to be, not just what commands to run.
Yeah.
And you can apply that description safely anytime.
Precisely. That's the core idea. And finally, the sources mention it's highly extensible. There's this huge ecosystem of modules and plugins. Think of them as pre-built tools for specific jobs.
Like building blocks.
Kind of, yeah. And especially with Ansible collections now, if you need to automate something, chances are good someone's already built a module for it, or you can build your own.
Okay, wow. So simple with YAML, easy to roll out because it's agentless, powerful enough for complex stuff, safe because it's idempotent, and flexible with all those modules. That's quite a list. Let's peek under the hood then. What are the essential building blocks, the core concepts the sources define?
Yeah, the sources lay out the key terms pretty clearly. First up, you've got the control node. That's just the machine where you install Ansible and run your commands from. Your command center, basically.
Oh, got it. And the machines it's managing.
Those are the managed nodes or hosts, the servers, devices, whatever Ansible is talking to remotely.
Okay. Control node talks to managed nodes. How does it know which ones?
That's the inventory. It's usually just a file, like an INI or YAML file, that lists your managed nodes. You can organize them into groups, too, like web servers or databases. It tells Ansible what machines to target for specific tasks.
Control node, inventory for targets, managed nodes are the targets. Makes sense. But what actual work does it do?
Yeah.
The actions.
Those actions come from modules. The sources describe them as small, reusable bits of code. Each module does one specific thing: install a package, copy a file, manage a service, create a user, gather facts about the system. There are tons of built-in modules.
Okay, so modules are the individual tools. How do you string them together to do something useful, like set up a web server?
That's where playbooks come in. They're really the heart of Ansible. Written in that YAML format we talked about, playbooks define a sequence of plays. And each play essentially maps a group of hosts from your inventory to a list of tasks that should run on those hosts.
Ah, okay. So a task is like one step in the playbook, using a specific module with certain settings.
Exactly. A task is a single module call within a play.
Okay. Control node, managed nodes, inventory, modules, playbooks, tasks.
Got it.
The sources seem to emphasize those 6.
Yeah, if you understand those 6, you've got the basic structure of how Ansible works. So the next logical step is, how do you actually get it running?
Right. Installation. That happens on the control node, you said. What did the sources suggest for common setups?
For Linux, like Ubuntu or Debian, the usual way is using apt after adding the official Ansible PPA repository. Pretty standard. On macOS, Homebrew is the go-to package manager. Just brew install Ansible.
What about Windows? You mentioned it doesn't run natively there?
Correct. The sources are clear on this. The best way to run Ansible from Windows is using the Windows subsystem for Linux, WSL. You install WSL, pick a Linux distribution for it, and then just follow the Linux install steps inside WSL. It works really well.
Okay, so Ansible's installed in our control node. How do we double-check it's actually working?
Simple command, Ansible version. The sources show you what to expect in the output: the Ansible core version, the Python version it's using, config file paths, maybe some loaded collections. Seeing that confirms you're good to go.
Perfect. Installed, verified. Now, that tutorial source had a really basic first example, just pinging the hosts. Let's walk through that. It seems like a good way to make these concepts real and check connections.
Yeah, it's the classic hello world for Ansible, basically. Great first step. You start by creating an inventory file. The example uses inventory.ini. You list your target machines in there, maybe their host names or IP addresses. You can glitch them too, like putting web servers and listing hosts under it.
And the crucial part here is making sure your control node can actually connect, right? SSH usually.
Absolutely critical. Your control node needs passwordless SSH access, using keys as best practice, or working WinRM for Windows targets. Authentication has to be set up beforehand. Once you have the inventory, you create the playbook file. The example calls it pingtest.eml. Being YAML, it starts with the 3 dashes.
Okay. And inside that file, how's the ping test structured?
Well, playbook is made of plays. This one just has one play. It starts with name, which is just a description, like test connectivity to web servers, then hosts, tells it which group from your inventory to run on, so web servers in this case. After that comes tasks, which introduces the list of actions.
And for this simple test, there's only one task, calling that ping module.
Exactly. The task also gets a name, like ping the hosts, and then the actual module call is just ansible.builtin.ping. That's it. It tells Ansible to use its built-in ping module, which doesn't use ICMP ping, by the way. It actually tries to connect via SSH WinRM and run a tiny Python script to verify the connection and Python interpreter.
Ah, good distinction. So we've got our inventory.ini with targets and pingtest.eml telling Ansible to use the ping module on the web servers. How do we run it?
From your terminal on the control node, you use the command Ansible playbook. So it'd be Ansible playbook di inventory.ini pingtest.eml. The I flag points to your inventory file.
Okay. And assuming it works, Ansible connects. What should we see?
You'll see output as Ansible runs through the play and tasks. For each host, you should see something like OK hostname. And the key part is the play recap at the very end. For a successful ping test on, say, 2 hosts, you'd want to see something like OK2 changed, unreachable 0, failed 0. Seeing 0 unreachable and 0 failed is the goal. That confirms Ansible can talk to your machines.
Perfect. Connectivity established. That's step 1 checked off. But like you said, the real point is automating actual work. So beyond just pinging, what are some common practical things the sources show you can do right away with modules? Moving past the hello world.
Absolutely. Once you know you can connect, you can start doing useful stuff. The sources give some great examples, like installing packages. A task in your playbook might look like,
Install Nginx web server ansible.builtin.app.name.nginx.state.present.
Here, ansible.builtin.apt is the module for Debian Ubuntu systems.name.jenks says which package, and state present tells Ansible make sure this is installed. That's the idempotency bit.
Yep.
If it's already there, this task does nothing except report OK.
And you'd use a different module like yum or DNF for Red Hat-based systems.
Exactly. Ansible.builtin.yum or ansible.builtin.dnf. The principle is the same.
Okay, installing packages is fundamental. What about getting configuration files onto the machines?
Super common task. To use the ansible.builtin.copy module for that, something like YAML.
Copy our custom application config, ansible.builtin.copy, src, local path on control node, atcom.com.con, dev.etc, myapp.com.owner.abusers.group.appgroup.mode, 06444.
This copies the file from your control node, src, to the manage node desk.
Yep.
And you can even set the owner, group, and file permissions right there.
Nice. And managing services. Starting, stopping, restarting.
Yep, another daily task. The ansible.builtin.service module handles that. You could have a task like YAML.
Make sure the Nginx service is running and enabled at boot.ansible.builtin.service.name.nginx.state.started, enabled.true.
This makes sure the Nginx service is currently running state.started and also set start automatically when the server boots enabled.true.
And user accounts.
There's ansible.builtin.user for that. Creating users, setting their home directories, managing group memberships, SSH keys, all that stuff, consistently across all your machines. These are just basics, but you see how you combine these modules in a playbook to, say, completely set up a standard web server from scratch.
Yeah, you can see how it builds up. Now, as these playbooks get bigger, maybe setting up a whole database server or a complex app stack, the YAML files could get pretty long and maybe hard to manage, right? The sources mentioned something called roles.
That's right. Roles are basically Ansible's way of organizing and packaging automation content. You bundle tasks, associated files like templates or config snippets, and variables together into a reusable structure. It helps keep larger projects clean, makes automation easier to share and reuse. It's definitely the way to go as your automation gets more complex. And it's worth remembering, the sources point out Ansible isn't just for Linux. It handles Windows via WinRM, BSD systems, even ZOS Unix. And network automation is another whole area where it's widely used.
Okay, one really practical point. When you're copying config files or setting things up, you inevitably run into sensitive information. Passwords, API keys, certificates. Putting those directly into your playbook YAML seems like a really bad idea from a security perspective, especially if you're using version control like Git. How does Ansible handle secrets?
Yeah, that's absolutely critical. You definitely don't want secrets in plain text. The solution provided by Ansible, highlighted in the sources, is Ansible Vault. Vault is a built-in feature that lets you encrypt sensitive data. You can encrypt entire files, like variable files containing passwords, or even just specific strings within a YAML file.
How does that work when you run the playbook?
When you run Ansible Playbook, if it encounters Vault encrypted data, it will prompt you for the Vault password. It then decrypts the data only in memory for the duration of the run. The files on disk stay encrypted. This means you can safely commit your playbooks, including encrypted variable files, to version control without exposing your secrets.
Okay, that sounds essential for any real-world use. So we've got the basics, seen some examples, touched on organizing with roles, and securing secrets with Vault. For listeners who are thinking, okay, I get the basics, I want to go deeper, where do the sources recommend they go next for learning and maybe getting involved?
The number one resource is definitely the official Ansible documentation. It's really comprehensive. The sources specifically mention the Getting Started with Ansible section and also Getting Started with Execution Environments as good places to continue. Execution environments are about containerized Ansible runtimes, which is becoming more common.
What about finding help or seeing what others have built?
For community interaction, there's the Ansible Community Forum and the Ansible blog. And to find pre-built automation content, those roles and collections we talked about, the place to go is Ansible Galaxy. It's like a repository for reusable Ansible code. The documentation also has things like porting guides, which are useful when you need to upgrade to a new Ansible version. And of course, detailed reference sections covering every single module, every playbook keyword, configuration settings, FAQs, it's all there.
Sounds like a really well-supported project, both officially and by the community. The sources mentioned a release cycle. Twice a year for major versions?
Yeah, roughly twice a year for major releases of the core package. But the sources note that the core itself changes relatively slowly, focusing on stability. Most of the functionality, the modules and plugins, lives in Ansible collections. These are developed and released independently, often much faster, by the community and vendors. It's a model that allows the capabilities to expand quickly while keeping the core engine stable. You can find roadmaps for both core and collections online.
So pulling all this together from the sources, Ansible really seems to hit a sweet spot. The simplicity of YAML, being agentless, the power and idempotency backed by a strong community and ecosystem, it makes tackling those repetitive, error-prone IT tasks seem much more achievable. It's not just running commands remotely, it's about defining and enforcing the state of your systems.
Exactly. It gives you the tools to shift from constantly reacting to problems towards proactively managing your infrastructure with automation that's version controlled and repeatable.
So maybe the final thought for you, the listener, is this. Think about that shift, moving away from manual tweaks or fragile scripts towards defining your desired state in Ansible playbooks, stored in Git. How could that change your day-to-day? How might it change how you approach managing your systems? And maybe more practically, what's the single most annoying repetitive task you do right now? Just one thing. Could you break that down? Could you start automating just that one task using a few Ansible modules? That might be the perfect way to take what we've discussed and make it real.